Good afternoon, all you mathletes out there. This is Mr. Ruger again. What I want to do right now is I want to take a look at the distance formula for two reasons. The distance formula works both for how to figure out or round the answer in your calculator, and also how to find an exact answer using simplifying radicals. But here's your typical problem where it gives you two ordered pairs that you're going to have to find the distance between. As you can tell, I don't have the same coordinate for the x or the y value, so it means it's not going to be a horizontal or vertical line, so I can't just count units. I know that the distance formula is the square root of some sort of facsimile of y2 minus y1 squared plus x2 minus x1 squared. We talked in class that you could say x2 minus x1 squared plus y2 minus y1 squared because they're connected by addition, so they're a commutative property. I can do either one of those. Also, for the sake of consistency, I could do x1 minus x2 and y1 minus y2 is because I'm squaring them. I'm always going to get the same answer, because even if I get a negative in one and a positive in the other, when I square them, they're always going to be positive. But for this sake, let's just say that since this guy is the first one, we'll say x1, y1, and x2, y2. So we go ahead and we go through the process where y2 is going to be negative 3 minus 5 squared plus negative 4 minus 9 squared. Now that's going to be my absolute value. Negative 3 minus 5, that's going to be a negative 8. We square it, we get 64. See, that negative went away. Plus negative 4 minus 9, that gives me a negative 13. That gives me a positive 169. Okay? Now, here's a moment where if you're using your calculator, you have to make sure that you are not, I'll put a little sidebar over here. In your calculator, there's a difference between negative 3 squared and negative 3 squared. Your calculator will read this and give you negative 9. This one will give you a positive 9, because this says the opposite of 3 squared, whereas this says negative 3 squared. You got to be careful with syntax and language. Remember, math is a language. But moving on, we get this, my distance is going to equal the square root of 64 and 169. That's going to give me, 233? 233? Yeah, I like that. 233. And we can go ahead and we go through the process of using your calculator. You can do second x squared, and that's going to make your calculator look like this. And then you just type in 233. Close it. Make sure you close it. Maybe not right away, but later on in math, you're going to need to make sure that you have your right and left bounds in. Hit enter, and that's going to give you your decimal answer. Now, if you're looking for the exact answer, once again, let's just talk about that. Second x squared, second then x squared, and then 233, and then your equals button. So that's what I'm kind of looking at as far as how to take the square root. If I'm looking for exact, then I need to find perfect squares. Perfect squares in there, I'm trying to look at, it's odd, so it's not divisible by 2. The digits add up to 8, so it's not divisible by 3. So if it's not divisible by 2, it's not divisible by 4. Or 8, it's not divisible by 3, so it's not divisible by 6. It's not going to be divisible by 9. It doesn't end in a 0, so it's not divisible by 10. We're starting to get a picture that maybe 233 is potentially a prime number. If you want to hang on just a second, let's go figure that out. As we pick up some problems, here's my little trusty-dusty calculator. Let's see if we can't 233. We divide it by, say, 11, and we get 21.18. It's close, but that's not right. 233 divided by 13 gives me 17. 233 divided by 6, that's 215, and that gives me 14. So we checked them, and we see that we checked up to 10 and got 21. We can do 233 divided by 12, but we know that that's an even one, so that's not going to work. But as you can see, the factors are 13 and 17.9, 15 and 14. They've already passed each other. So this number, unfortunately, is prime. Well, for some of you it might be fortunately. So that means that the answer, an exact answer for this one, is just going to be the square root of 233.